Hello everyone. We will now see the uh, basics of introduction to semiconductors in our subject electronic devices, which has been taught in the third semester of electronics and communication engineering students. So first we see the what will be the syllabus of our subject. In unit 1 we have that introduction to the semiconductor physics, that how we can distinguish a material as semiconductor or conductor or insulator, and what are the behind the quantum mechanics behind these materials. Then in second unit we will see that what how can energy bands in a semiconductors behave and how they are formed. Then in unit 3 we will talk about the devices which has been made using the semiconductors. What are the devices that the electronic devices which has been manufactured using the application of semiconductor. Then in fourth unit we will see one of the such devices which we called a bipolar junction transistor. Now transistors are very much useful electronic devices which come into play when we have been going towards the logical programming or logical circuits, because using a transistor you can easily manufacture the logical devices like microcontroller, microprocessors. The BJTs or transistors have been have been a great invention in their times, which has been used to modernize the electronic circuitry in the field of engineering at that time. Then in fifth unit we will see one of such transistor like field effect transistor, which has been improvement over the BJTs in terms of power consumptions and logical interpretations. So I will recommend we will use the Banji treatment of solid state electronic device, which has been used as a reference textbook. Then we have Niemann semiconductor physics and devices for unit 1, and for unit 4 and for unit 5 I will recommend that we can use essence that is the physics of semiconductor devices, or you can also use CV DIS and M colon for operation and modeling of MOS transistor. Now moving towards next part, how can we distinguish the electronic material? What is the main purpose of the electronic material? The goal of the electronic material is to generate and control the flow of electric current. So like we have resistance, capacitors and inductors. These are the electrical material, but the current flow through them, you cannot control the current. Like in a resistor you cannot control the current, but how we will manufacture the resistor? Okay, using the electronic material. So how can we distinguish electronic material? Electronic material has been categorized in three different categories. One is conductor, and second is insulator, and third is semiconductor. Now what are conductors? As the name suggests, these exhibit a very low resistance which allow a electric current flow. Now what means the electric current flow? Now as the resistance is the capability of a device of a material to restrict the flow of electrons through them. So the conductors are the material which will not restrict that flow of electrons that much. So they have very low resistance. Then we have insulators. Insulators have very high resistance which surpasses the electric current flow. Means they have not allowed the flow of electrons through them, because they have very, we will see what was the reason behind that. Then we have one very important category of electronic materials, which is semiconductor. Semiconductor will allow or suppress the flow of electrons through them, depending upon whatever the condition you will apply at the semiconductor. So at semiconductors have been invented because you can modify the flow of electrons through them, which cannot be done in conductors and insulators. Now this is the one atomic diagram of atomic structure of copper element. Now copper has the nucleus, as the atomic number is 29, so number of protons and electrons in the copper atom is 29. Now this is the innermost orbit of the copper atom. Now innermost orbit, as we already know, the innermost orbit will be very much attached to the nucleus, so the it is very much difficult to take the electrons away from this orbit, because it has the strongest force attached to the nucleus, so we cannot take out the atom from the innermost orbit. Now as the orbits length, or we call distance, increases from innermost orbit to the outermost orbit, we will see that the force has been decreases as we move towards outer orbit. So the outermost orbit has the weakest force. It has the weakest force. So it will be very easy to take out this electron from the outermost orbit. So what we have, the conductor, so the copper atom, the atomic structure is usually have one electrons in their outermost shell. That is the quality of a good conductor. For example, metals. Most metals, every metal is a good conductor. So it is called the valence electron. The outermost orbit electron is called the valence electron of that material. Then it is easily stripped from the atom, producing a current flow. So as we can easily take out this electron from the outermost orbit, it is very much easy. That is that will allow the flow of electrons to that material. Moving towards the next part, we have insulators. Now insulators have very high resistance, so the current does not flow through them. For example, you would see the glass, the ceramics, the plastics, and the woods. You cannot these materials cannot allow the flow of electrons to flow through them, because it has very high tendency to restrict the flow of electrons. Now most insulators are compound, because these are not metals, or we called a single element. It is not a single element. These are compounds. So it will be manufactured with using too many elements with these material. Now atoms are the atoms are tightly bound to one another, so the electrons are difficult to strip away. Means the bonding between the atoms is very high, that they will not allow any force to break the bonding between the atoms, so that the current will flow. Because until and unless the atomic bonding between the atoms has not been broken, you cannot get a free electron. And whenever you cannot get the free electrons, the flow of current will not be allowed. So insulators have very high resistance to the current flow through them. Then we have come to our very new category of material, which is semiconductor. Now, semiconductors are the material that are essentially conditioned as a good conductor or a good insulator, depending upon what are the condition you are applying. Like uh, at at 0 Kelvin, when in the purest form, the semiconductor does not allow to the current to flow through them at uh, uh, at natural conditions. So silicon and germaniums are basically a very good are categorized as a semiconductor, and silicon is the best use because it has the highest thermal stability. Means as the temperature increases, it will not allow so much to break the bonds between the atoms. So silicon have the higher thermal stability as the temperature, as we increase the temperature. So these are the semiconductors. Then moving to the, if we see the energy band gaps of all three materials, we see the conductors. In the conductors, we have fully filled. We have fully filled bands. Means the conduction band. This is the conduction band. This is the conduction band, and this is the valence band. And there is the overlapping. We call it is the overlapping of conduction band and valence band. So whenever the overlapping of conduction and valence band occur, then whatever the electrons here, it will move easily to the conduction band. It does not require so much force. So at as soon as you will apply some electric field, or you can apply some external force, so that the electrons will suddenly move from valence band to the conduction band, and the current will start flow. So does not require any extra energy. Then we come to the insulators. Now insulators, they have very much band gap. This is the very much band gap between a conduction band and a valence band. So the large, not high, the large band gap, the band gap is so much large that no amount of energy or force, external force, will be capable to take the electron from valence band to conduction band. So there is no force available, no amount of force or no amount of external energy available which can change the electrons, which will move the electrons from the valence band to the conduction band. So these type are called insulators. Like we already see rubber, woods, glass, they will not allow the flow of electric current through them. Then we called semiconductors. Now semiconductors have not very much, but some amount of band gap. But at room temperature, if we have not apply any external force, okay. If you not apply any external force, or you have not changed the atomic structure, or you have not add any impurity to the material, or at 0 Kelvin. So at these temperature or these condition, if not you have fulfilled, then the energy gap is there. But as soon as you apply some temperature, as you increase the temperature, suppose if the temperature increases, or you will apply a doping. Doping means we will apply some other materials to bond with these, to mix with the semiconductors material, or you apply any external electric field. So with amount of these energies, what we have, the electrons from the valence band get so much energy, that amount of energy, that is the band gap is so much small as compared to the insulators, but much larger than the conductor. So in between the insulator and the conductor we call is semiconductor. So as soon as the electrons get the energy from some external force or external field, it will, what it will do, it will get the energy and it will move towards the conduction band, jump towards the conduction band. So it may be possible because the band gap is very much small. So this is what we call that is why it, if it gets the energy, then the conduction band get a free electron. Now free electron is possible, then the flow of charge, flow of electron is possible. As the flow of electron is possible, it can apply, you can it can allow the current flow through them. So if we see the periodic table, then our semiconductor basically come at the group 4 elements. Group 4 elements. So group 4 elements basically withstand the property of what we call these property, that we call it a semiconductor, means you can't modify the conductivity of a material as depending upon whatever the condition you are applying. So, and if you see, the most of the metals are in the group 1 and group 2 of the periodic table, and we will see that how the doping, that is the adding of some material like group 3 material or group 5 material to the semiconductors, to depending upon whatever the type of semiconductor it will become. So if we see the periodic table, the group 4 elements will possess the capability to be called as a semiconductor. Group 3 and group 4 elements can be used to used as a doping atom to be provided to the semiconductor. Moving to the semiconductor valence orbit, if we see, this is the valence orbit of a semiconductor like silicon. So this is the innermost shell. We have 2 electrons in the innermost shell, then we have 6 electrons in the middle shell, then in the valence orbit or in the outermost orbit we have 4 electrons. So as we see that in the most element which possesses the good conductor, or we say as a good conductor, they will have the less number of electrons in the outermost shell. So as you see, and those elements which have not used as a good conductor or bad conductor, they have more number of electrons in the valence end, and the semiconductor come in between that. Moving towards next part, what should be the properties of a semiconductor? Means the semiconductor can conduct electricity under any preferable condition. So this unique property is what that make them the semiconductor. As I already told you, that you can modify the electrical conductivity of a semiconductor material, which is not something that possessed by any, like in conductor you cannot change the conductivity of a metals, because it is a conductor, but you cannot increase or you cannot make it is an insulator. There is no time that a conductor cannot allow a flow of electrons through them. You cannot do that. And in insulator, you cannot allow, you cannot do that any amount of force or any amount of any external activity will allow, which will give the properties that insulator can allow a flow of electrons to them. So they have not possess such property that they will modify the conductivity of their conductive property of them. But a semiconductor possesses but a semiconductor possesses such property that it can modify the conductivity, like it can modify the flow of charge carrier, or what we call electrons, through them in very controlled manner. Means you can control the flow of electron or flow of current through them. It is upon you. So unlike the conductors, the charge carrying semiconductor arise only because of external energy, that is already I told you, like thermal agitation. It causes a certain number of valence electron to cause an energy gap, and jump means only a certain amount of electrons can jump from a valence band to conduction band. You can see, you can allow all of them. Like in conductors, they have no choice. All the electrons from the valence band will jump to the conduction band. In the insulator, there is none of the valence band electrons will jump to the conduction band. But in semiconductor, you can allow some of the valence electrons to jump from the valence band to the conduction band. So whatever the resistivity of a semiconductor can be changed from 10 to power minus 5 to 10 to power 6, and the you see that is the conductivity also changes from 10 to power 5 to 10 to power minus 6, because what we call resistivity is what we call inversely proportional to the conductivity. Then temperature, the semiconductor possesses the negative temperature coefficient of resistance. What it does means the resistance increases, or resistance increases as we decreases as we increase the temperature. That means as you increase the temperature, the resistance of a semiconductor is decreases. Unlike the conductors possess the positive temperature coefficient of resistance. Means as you increase the temperature of a conductors, its resistivity also increases. Now current flow is due to electrons and holes both. Now holes is the charge carrier which is only available in semiconductor. These are also known as the absence of electrons. Absence of electrons. So it will not be possessed in in conductors or insulators. It will only present in terms of semiconductors. Now moving next, what should be the crystal lattice of a means the inside inner lattice of a inner structure of a semiconductor. Now as you see that semiconductor possesses so many unique property, one of them to modify the conductivity of a their conductivity. The another property that they will possess is the crystal lattice. The semiconductor, this is the unique capability of a semiconductor, that their ability to link together in a form of physical structure called crystal lattice, like this. At proper at a same distance, the atoms are linked at a same distance with the other atoms. These links are called covalent bonds. So they have been linked using the covalent bonds with each other, and each atom have 4 electrons in outer shells. So at silicon has 4 electrons in the outer cells. These electrons have this atom has 4 electrons in the outer cells, so it will bond with this, and this will bond with this to complete their octet. And as we know that as the octet completed, the bond has been fixed, and you cannot there is no free electrons available until and unless you will apply some external force through them. Then moving to next part, we have what does the resistivity of semiconductors go, why the resistivity of semiconductor go down with the temperature. Why it causes that negative temperature of coefficient? Because the resistivity decreases as the temperature increases, because the number of charge carriers increases rapidly in as we increase the temperature, making a fraction change in the temperature coefficient as negative. Means, as you see that as the electron as we increase the temperature, some of the valence electrons will get the energy and will jump. Like this is the conduction band and this is the valence band. Valence band have electrons and this is empty. As temperature increases, some electrons will move towards it, making this as positive, making it is a positive. Means these are electrons. Suppose these are electrons. These all are electrons. Okay. As the electron move towards this vacancy has been vacant with positive charge, which we called holes. Okay. Now holes causes the positive charge, and this positive charge, this electron, they will bond and they will make as a electron hole pair. Now electron hole pair has been created. So as we increase the temperature, more and more number of electrons will be broken and more electrons will move towards the conduction band. This will increase the conductivity. So more number of free electrons will available in the conduction band. So the more conductivity it will possess. Moving towards the next part, what should be the properties of a semiconductor? Now, if we see the property that at 0 Kelvin, there is no external force, there is no thermal agitation, so there is no electrons will move from the valence band to the conduction band. So it will act as a insulator at 0 Kelvin. Now, as the temperature increases, it will act as a conductor. So that is why it is known as semiconductor. Now, what should be the electric property? Electric property can be modified, and the power loss will be less. Now, it is a very small size and lightweight, and the resistance decreases with increasing temperature. Thank you.